So see here, this is about tree set. So tree sets had some like additional things, and basically you will see it's not linked with hash set and like word linked hash set. But yeah, couple of things it is related. The set implementation is there. So set interface child is sorted set, and then there is a one another interface that is navigable set, and navigable set is the parent of tree set. You can see here. The tree set is basically a class. Now you are familiar with like comparable and comparator, so you can understand it better way. That what is a tree set. So basically, when you start storing data in the tree set, by default natural sorting order, it will store the data. You can see maintain ascending order. It means whatever the data you are storing here, it will be by default stored in the natural order sorting order. Contains unique element like hash set. Like you have already seen about hash set, which contains only unique element. So same like that. Access and retrieval time is quite fast. Don't doesn't allow null. So this is something important. Null is not allowed here. Okay. Actually, storage time you are allowed, but accessing time it will like so throw some error. So you will see that kind of things. And this is non-synchronized, bit faster, not good for what you call multi-threading environment. So that's why it's faster. You can see here, this is the signature of that class tree set. E type, it means like data type you can define. Extend abstract set. This is the class and implements navigable set. You can see navigable set is here, and clonable and serializable interface are also the parent of that. So these are the things you can see here. Just minimize this and let me show you some examples. Come here in the Eclipse and I will look for preset. Already have set and map examples, right? I think that examples I will find here. The tree set. Preset. We have some preset example here. Mostly it is same, but first go to that particular class and see what is things given, what are the methods and all such things are present there. I'm going to the show view and coming to the outline. You can see these are the things present, and if I make it on green one, then you will see more better way. The three shaders like these constructors are there. You can have blank one. This is like collections you can pass. It will automatically sort. This is what comparator you can pass also. So in which order you want to sort, that is also possible, and sorted set also data type you can pass. So these are the four constructor, and add method is there, add all method is there, ceiling is there, clear is there, clone is there, comparator is there, contents is there, descending iterator is there, descending set is there, first is there, floor is there, date set is there. So not all are important, but couple of things are important, which I will try to show you up. So I already have those examples. Just I have to give demo for those things. That what are the things. Mostly people are not using Treeset much in automation perspective. Our most of the time, like we are going with hash set, linked hash set also very less people are using. You have to know the concept because in the interview, they will be keep on asking about whether you know about tree set concepts or not. So tree set concept you should know. Like mostly I think it's from Java 1.2, but let me confirm. So it is from the Java 1.2. And what are the other classes it is related to? You can see it is saying that hash set, comparable, comparator, and tree map. These are the things you can also refer for more concept about tree set. So this is the signature I was talking about. Tree set, extend abstract set. Abstract set is like class. Navigable set is an interface. You can see a clonable and serializable. So these are the main things of the tree set. And it is also present in the java.util package. You can see here. So tree set is there, like tree map is there. So if you go with the tree set concept, you will somehow get the concept of tree map as well. So now I'm coming to examples part. So this is the first example of the tree set. What I'm trying to do, I'm creating the string type tree set. And by default, natural sorting order. Natural sorting order means like this will be stored at the first position. This will be stored at the last position. This will be stored in the middle position. Printing wise also, same kind of all logics what we have seen in the past. All those will be there, but you can use iterated and all such things. So let me comment this part. We have a hash set example. I can take more data to show you. I will try to add null as well to see what happens when I try to add null. You can see here, I'm not getting any compilation error. 23 compilation wise, it's not no problem. But when I will go for the printing, I think you will get some error. So let me show you that part. Run as Java application. You can see here, it is saying that null pointer exception. So at the time of addition, it is not having any issue. At the time of compilation, it is not issue. But at the time of real, like what you call addition, it is having issue. If I put it at the first position, nothing will be. Right click, run as Java application. It is saying that at line number 11, you have something which is not allowed. Okay, so low, and let's go and fix that. You see, null is not allowed. If you see by debug mode, then you can have a better understanding. Toggle breakpoint and run it in the debug mode. So first time, other factors also we have to see. That's why I have run into the debug mode, the multiplying factor and also. Here, the tree set is created here. Basically, internally, it is a map. So tree map structure is there. You can see. So when the tree map structure is there, so comparator interface is coming into the picture, and by default, natural sorting order will be followed. It has a key, and it has a value as well. The value, the value will be there, and one is key will be there. So let me try to add couple of variables, then you will see. But since here it is a null, and null is not allowed. You see here, when I'm trying to add here, it is showing that some exception occurred. Okay. It is trying to compare with two values and which is not matching, then it is trying to throw some kind of exception. So let me come back. This is the exception. Now coming back to the Java perspective, I already told you that null is not allowed, so I have already commented it out. So now I'm going again and running in the debug mode. Here it's size and everything is not coming here because as of now initially 0 0 everything. When I will add first element, then it will show you the size. So I'm trying to add first element. When I added first element, I'm trying to see that whether any size is there. Size is, I added multiple. Then this is the, and via this. So basically it is a tree structure. If you have gone through the data structure, so some root and node concepts are coming. Let me explain that first. Let's paint. It is stored like this, and one is left and one is right. Okay. Again, it will, every node will have a left and right. So like this, it will internally store the data. So one is root. You can see a root one. So root will be like the first one. And after that, the first element was Ravi. So it stored Ravi, and it is having key, and then it having like left and right pointers. You can see here. So something, first element is root, like no Ravi, then it is having like first left and right pointers are there. And once I started adding more values, so what it will do, it will automatically adjust. One will become like root, then something left, something right, and by default natural sorting order it will follow, and it will be stored down. So see here, as of now I have stored Ravi, Vijay, Azay, and 2. So it's coming here. Then you coming to the Ravi, you can see here it is stored and it has a value called, then it is pointing to this Ravi. Okay, like this data is stored, and it has a left. A left is pointing to what? Ajay. So Ajay is put to the left, and right is right is, I think it's automatically adjusting because of the natural sorting order. So internally, like how it is managed, it's a complex thing. I have to look into that how it is internally stored. But basically, it's a kind of node structure. So it will store like left and right. So this will call left and this will call right. And then again, it will point to some next object. Next object will also have left and right. So like this kind of a structure, it's internally maintaining. You see here, any node you go, you will check it has a left and right kind of thing. So this is the root one. Root one is the first one. And once you go there, then it has a left and it has a right here. So you can see right is something, it is pointing to Vijay. Okay, and left it is pointing to Ajay. So Ravi was the first one, then Vijay and Ajay. It's like it is being stored like that. When I'm adding to something, more nodes will be added like that. The total 4 elements I have stored. Coming here. One by one, I will just keep on adding the data, and you can see 4, 5. There is nothing called initial capacity kind of thing. I cannot find that option here. So no capacity and all such things are there by default. I think should be 16. I cannot see anything like that here. I keep on adding 9, 10, 11, 12. Let me add more one. I just want to check some capacities. And it will always store unique values, no duplicates allowed, but by default natural sorting order. So we have the values, and if I run this, just see normal run I'm doing, you can see by default natural sorting order it is following. Okay, so this is something important point about this. It will follow natural sorting order. That is Ajay. Ajay and Ajay one is there. Where is Ajay one? Ajay one is not. This is something 61, 71. And capital small also considered. It's like who has uh, index number, you can see 65 is started for capital A. So those kind of things also being considered. So tree map, going here, tree sheet, I'm going here. You can see that how many values we have added. And again, I will run in the debug mode just to check whether what is the load factor, multiplying factor kind. Debug as Java application. Added. There is nothing such like that. It is coming in form. I expand this. Just want to find if anything is coming like that, but it is not coming. 5, 6, 7, 8, 9, 10, 11, 12, 13. If I added the 13th month, so there is nothing such information is mentioned that this will be multiplying factor, this will be load factor kind of thing. So no information regarding that. So far I haven't found. Because it's a node structure, that's why it is like just left and right keep on maintaining. And that's why it is not having some kind of fixed size. It's a dynamic kind of thing. Okay. So I think that is the reason, but let me keep on adding, then I can check. 16 is also done. 17, 18. So now I'm printing here. All the values are printed over here. But on the in the ascending order it is printing, but you see here capital is treated as a different and small is treated as a different. So why? Because of the ASCII character codes. So capital E start from 65 and small a start from the 97. So always small case will be the less precedence. Capital will be more precedence because of the ASCII integer codes. So let me complete this. This execution is completed. Then I'm coming back to the Java. This is one thing. Null, you have already seen the demo and coming back to here. Unique. So unique is there or not? You can check some duplicates value you try to add and you check that how many values it is showing. Run as Java application. Some duplicate values we have added deliberately, but you can check whether it is there or not. So no duplicate values are there. I have already copied and pasted couple of things. Ajay, Vijay too. So those things are not coming. Only one time it is printed. Ajay, Vijay. Ajay is also one time. Vijay is also one time. More access and retrieval time quite fast. That's okay. Doesn't allow null that we have already tested. And non-synchronized means it's not good for multi-threading. We will try to use with multi-threading and common reading writing operation will be a complex things to manage. It's not possible for it. First, once you try to, reason is that once you try to access the common object, then it will show you concurrent modification exception, CME, that is called in short form. It means more than one thread are trying to access a particular resources. So that time, if one process is already occupied with one resource and the second process wants to access, because it's non-synchronized. So non-synchronized means anyone can go and like try to access. So if more than one process is accessing one resource or common memory location, then it will show you concurrent modification exception. So this is the main thing about Treeset, but I like to show you more demo, some of the more methods. So this is some standard way of printing, but you can just convert it to a stream. You can use for each method. Everything which you have already seen in the past, all such things will be possible. You can see here, if ascending order is there, but you want to print in the descending order. So how you will do that? So we have a descending iterator. So via descending iterator, you can achieve that task. And just remember, collections.short is not available for every collections classes and methods. It's just available for list. So traversing element through iterated and descending order. You can check this, the printing this and this, what it is printing. So this is printing in the reverse order. This is for your information. We have a iterator and we have a descending iterator as well. And descending iterator, they have given a tree set. You can see here. One is clear. You can use clear. So that's the same thing. I will try to show you examples about the tree set using collections. In the tree set, variable initialization, you can pass any collections thing. Let me comment this part. In this part, see here, this I don't need. This is not allowed. Okay, I don't need this. I have couple of values here, which all are string here, and it's an array list. So array list, you know, like it can contain duplicates and everything is, so that is possible. So what I need to do, I will just print it once and then I will pass it to the creation of default tree set. That you can create one array list and then on the basis of array list, you can convert it into tree set. How we will do that? Run H Java application. You can see here we have a tree set and via that I'm adding. Here I have to print list. So we have a array list and we are printing that array list, but with the help of array list, I want to convert it into the tree set. So how I will do that? So earlier you have seen how we were creating the tree set. So in the creation time only, you can pass that and then you can get it as a tree set. What you will do here, this collection, whatever the name it is here, this collection, you pass it here. And it's allowed. Why it's allowed here? Why it's allowed? Because when you go to this tree shade, you see there are 4 type of constructors allowed. As one constructor is saying that you can pass any collections. One constructor is saying that you can pass any comparator things. So means for that you have to create any anonymous kind of thing on a particular basis of what you call. So that you have object data type, custom object data type. And on a particular field you want to perform the tree shades operation. So then you have to pass this comparator thing. And then basis on comparator, you can do the sorting for. So that example also I will show you. String integer is okay, but better you use comparator things. This is just a basic form thing. It's okay. So we have created one what you call tree sheet, and this time I have given a name as set1. And then when I print it, So this is the tree sheet, and whatever the value you have passed, first it will be converted to the unique one and then it will be converted to the sorted one. So two things you will see here. Even if it is a null, it's not allowed as run as Java application. You can see it is sorted in the ascending order as well. So this was the array list, which it was containing some duplicates. So first unique things are filtered and then sorting order is applied. So two things you will having when you will be using Treeset. One I have what you call comparator interface schema. So for that I have to go to the custom data type. Let me see if I have the example, then it will save my time. Otherwise I will have to find that example. Already have here. Okay. Let me see if I have that example. This is of integer. You can just see the integer one also. This is just to convert a tree sheet integer array. This is the example of that, but I want to show you that tree sheet also works on the integer. So string I will show, integer I will show, then I will move to the custom data type. And in custom data type, what you have to do, you have to pass the comparator things, which you want the sorting order. So let me run that. You can see it is coming in the sorted order. This is one thing. One is Paul first and Paul last. Basically, Paul first and Paul last. It will give you highest and lowest. Okay. And it has some property which I'll show you. It retrieves and removes. Okay. It means first it will show you the data and then it will remove the data as well. That particular. This is something. But I think there are methods which gives you first and last. First and last you can use. That is also possible. Let me copy and paste. One is first and last, and one is Paul first, Paul last. See the demo that if you are using Paul first and Paul last, so what will happen? And if you are using only first and last, then what will happen? After using Paul first and Paul last, I am just trying to print once. The first time I have printed it like this. Next time I have fetched first and last, so it will not remove. You see the mouse returns the first, means lowest element, and this returns the last, means the highest element. Paul first and Paul last. What it will do? It will remove the element. After that, if you want to print that, then it will give you something output like. To show you, right click, run as Java application. The Java application I'm getting. Earlier it was 11, 12, 13, 18, 20, 24, 66. So it is saying that first and last. So first and last already printed. After that, I applied Paul first, Paul last. So you see here 11 and 66 are gone. You can see, right? Paul first and Paul last. Means there are no changes in the earlier list and after list. But you are using Paul first and Paul last. First is first and last, and second time using Paul first and Paul last. So if you are using first and last, so there is no change. This is same as this. But next time I'm using what? Next time I'm using Paul first and Paul last. So when I'm using Paul first, so it will display the value, but it will be removed. 66 also displayed and removed. And after this, when I'm printing here, line number 43, so you see the final output I'm getting like that. You want to display and remove one by one, so you can put it in the loop as well, these methods. So this is something example of tree sheet for the integer, but I want to show you a tree sheet example, the basis of custom data type. This we have already seen, tree sheet demo. This we have already seen. This is almost same. No need to. This is just a string one. We have already seen. Now this one, tree sheet book custom data type. This example. So what I am trying to do, it has a book class. If you go to the book class, there is no comparator and comparable logic has been written. Okay. So what we have to do before implementation, you have to write the logic. If I'm going there, see how I have tried to use this examples already I have, so no worries. What I have to do when I'm designing the book class, I have to design some getter methods. So I have ID, quantity, name, author, publisher, 5 fields I have. And for 5 fields, I have a 5 getter methods. Any value, if you want to do the sorting, you can just pass that method and then you can perform the sorting. And this is something one constructor I have written, initialize. So we have a toString method as well. So if you want to use, then you can just pass the object and it will do the rest of the one. So design part is also completed. Now we have an implementation part. Implementation part, I have created the book type objects. So let me open side by side. It's done. This example is needed. Now I have and also in the implementation part, I have created 4 book type object B1, B2, B3, and B4. So same way I have given the values ID, name, author, publisher, and quantity. You can see here ID, name, author, publisher, and quantity. How many quantity? In this way, I have created 4 values. And once I'm trying to create the tree sheet, so there I'm putting some logic. Because once you go to the tree sheet class and you show this show view constructor, I want to show you that the comparator logic you can write here and then you can use. So I told you the best comparator is comparable dot compare method, which returns IC as a comparator. So it will like just minimize your code, and you have already seen that there are 3 ways. So no one wants to go with the longest one. Everyone wants the shortest code, right? Shortest code wise, you can just use that comparator logic, which you have already designed. You see here how I have tried to implement. Just see line number 16. That is the most important thing for you. I have this tree sheet set new tree sheet. Yes, I have told compiler that it will always just store book data type. And after that, it is asking for compare logic, comparator logic. Comparator logic, how I have defined comparator dot comparing. You already remember, you have already seen that. Then the class name, the method name. So which basis I want to sort? I want to sort on the basis of name. Okay. So it will do the sorting on the basis of. Then I just try to add, okay, 4 data type. Because it has multiple fields. So compiler will always confuse, right? That how we want to add the data. And if you have a custom data type, then That is the only way that you can go and get the sorting logic over. Otherwise, it will not be allowed. Once you are done here, I have a two-string method already. You have already showed you. Two-string method is there, so I will either go with this concept or I will just pass the book type object. That is it. So what I'm trying to print here, just given the name local variable dot get id local variable dot get name. So it will just point one by one everything and it will fetch all the values and then it will print up. You can see here quantity every 5 values I am getting. This is the collection. Collection is here, data type is here, and this is something any variable you can create and just it will point the book type. So dot get id get name everything I'm printing. You see it is by default sorting on the name basis name. So D, L, O, W. Four data types are there. The basis of that. But if you want to do the sorting on different, so just comment it. ID. Let me run this. So this is on the basis of ID. This is also done. Now, to your more example. Author, quantity. Let's this time sort on the basis of quantity. It's almost same. Let's see if you understand one, then it will be like same for all. So no worries. Only logic you have to written here just to minimize the code. Comparator logic is already developed. You have already designed that and just using class.reference and rest of the things it will do automatically. Basically, it is just helping to minimize the codes. Earlier, I was writing the code. Now it is doing everything for me. So this is just one liner, right? Java application. The basis of quantity it has sorted. And the reverse sorting that is also possible. After this, you put dot just for demo purpose. I'm trying to recollect the things because these things already we have already seen when we were discussing about comparator and comparable interfaces. You see here, I already have these things. Now I will just go and print it. You can see reverse sorting order is applied on that. And one more demo for the same thing I can use because I have a overridden two string method. This way I will comment this part not needed. This time I will just YZ I will take. I don't need south, but XYZ. So when I will print XYZ, so it will call the toString method and it will print everything. Name, author, publisher, quantity, everything. Just right click, run as Java application. You see here how the output I'm getting this time. So this is a better way to. You already know how to override the toString method and that is quite like helpful for you. If you have a custom data type, then you should always override toString method and that it will really help you at the time of print. Otherwise, you have to write your own logic. So this is my logic and this is something I have used compiler self and I have created toString methods. So this is something about Treeset. Anyone has any doubt?
No, Rajiv.
I have some work, like I need 5 minutes of like, okay, coming.
Yeah, hi Rajiv. Sorry.
Yeah, yeah.
Actually, I got disconnected and there is some problem. So I will discuss later.
Okay, so I'm just coming back in 5 minutes. Be online. I will come and start next topic. Some new other methods as well, if it is possible. Just
Okay.
based on coming back. Yeah, hi, I'm back. You can see here we have also saw on the what you call custom data type. So almost like a string we have seen, integer we have seen, custom data type we have seen. So for custom data type, consider that you just want to use it without comparator to check whether it is allowed or not. I believe it is not allowed, but I just want to show you whether it's allowed or not. So I'm not using any comparator logic. I just try to add this as a normal tree sheet. Okay, so not using any logic comparator one. Then you see in which order the data is being stored. When I'm running this, this is the problem. Compilation time it is not giving any error, but execution time it is showing that this is not possible. Collections set map demo.book cannot be cast to Java lang comparable because I have not written any logic on that, right? And if you don't write any comparable or comparator logic, so you cannot use custom data type for tree sheet. So that's the main problem. So either you have to go in book class or you have to write comparable logic or then comparator logic, then you can write use it like that. So that's the main thing. If you by mistake did like that, then this kind of issue you will face. So I told you that I believe it is not allowed, but at the time of compilation, it is not showing any error. It is designed like that. We have to use this any logic. We do it like this. Then I run it, then it should work. You can see it's working. So this is one more important thing about Treeset. Let me go more line. And remove and all such things you have already seen. Size you already know. Add you know. Add all you know. Filling is something nearby. That is not important. You can ignore that. Almost we have covered about Treeset. One more thing, if you don't what you call define the generics, then what will happen? Consider that I want to use a Treeset. Okay. And here I have defined as a string. So let me first copy this. State Treeset 4. What I'm trying to do, I'm removing this one. Index. When I'm removing that one, so it means it is saying that it is allowed to have any data type. But in the case of tree sheet, it that homogeneous property is applied. Homogeneous means based on the first data, it will define that what kind of data it is going to hold. So if once you have added the string, then you can second time if you try to add integer, then it will not allow. This is something for concept. You can add this concept. Say that I'm just using 100 as a integer. This is as a string. This is as an integer. And when I'm trying to print, to check how it is working. This is not needed. Remove this for demo. One I have added as a what? String. One I have added as an integer. Let me run this. You can see here class cast exception. String cannot be passed to the teacher. So if you add this first, the same thing will happen. The first position, it will not show any error, but the second position, it will show error. Because based on the first data, it is automatically casted into that. Only this kind of data will be allowed. You see here, first I'm adding 100. Okay. Second, I'm adding 200. So just to show you that this two will not show any error, but the third line will show error. You can see here, I'm getting the error in line number 14. See, and the error is java.lang integer cannot be cast to the string. Means everything is integer. It is already integer defined. So it is a homogeneous kind of thing. But what was happening when you having hash set and you don't define the generic part? It means in the angular bracket, what kind of data you are going to hold. If you don't define, then it was allowed that it can hold any kind of data. So to avoid that condition, I was just putting generic, and generic is not mandatory. This is just a guidelines to the compiler that my data type will be like that. In the say, what you call case of Treeset, it is a different way of working. It's a homogeneous object kind of collections. Means first, whatever the first value we define, that the only value it will be allowed. If I put null, the null is already not allowed. At the time of compilation, there is no issue. But when you try to run it, it will show you this an issue. Line number 12, I am getting issue, and this is due to null pointer exception. Null is not allowed. So this is something very important. It's working. This is also working fine. Treeset is completed. I remember everything we have covered about Treeset. As most of the things what is needed for. Mainly these things will also be not needed, but yeah. So far I have tried to cover a lot of things about Treeset. So Treeset is completed. Now we have next topic as a some lab exercises. So you can see whether you can, how much comfortable you are in doing this lab exercises. So create a set and insert and retrieve value. So it is talking about hash set. You can use hash set. You can use add method in the hash set and can add couple of values. So it will just contain unique one. And then it is saying that just retrieve the value. So retrieval how? It's via advanced for loop for each method, iterator, those kind of things you can use for just printing the value. So get the size of hash set. So via dot size method is there. You can always get that how many elements are present. Get the lowest and highest value from the Treeset. So this example we have just seen. First and last. Convert Treeset to the integer array. So this example also we have seen somewhere that this is the Treeset, you see, and I want to convert to the integer array. First you create the Treeset of integer and then you try to convert it into integer array. Let me show you this part. Array, it is just converting to the integer array and then you want to print it. Just run this and check whether it is working as expected or not. Yes. Here. Comment this part. See our value when I added this value was like that, and then I converted into the two array. So two array is converted to the integer array, and then I'm printing. It is printing like that. So values are same because tree sheet you already know the sorted order. So just it's converted and then I'm printing like this. So added a comma so that it will almost here. This is the lab exercises. Converted tree sheet to the integer array. Already converted. How you will convert via method. Via to array method, and the data type which you want to convert. So you put the data type over here, and then it will be converted to the particular integer array. Okay. So these are some syntax you have to learn and practice, that it will be helpful for you. So this is the lab exercise also we have completed. Now we have a new topic, and new topic will be discussed in the new, that is map. Map is an interface, and map has some subsequent child classes. So one is hash table, one is hash map, and hash map is the parent of linked hash map. So these two we have already interacted in the past as well. There's nothing new about that. The hash sheet is implemented, internally implementing hash map, and linked hash sheet was internally implementing linked hash map. And you see here how this is coming. So there is a separate structure of tree map. Tree map is like hot derived. Map is the parent of sorted map. Sorted map is the parent of navigable map, and navigable map is the parent of tree map. So this is the class. These blue things are interfaces, and this is legacy class. Legacy class means from the Java 1, it is there. So this is thread safe, and these other things are non-thread safe, means faster in execution and performance. This is bit slow and good for multi-threading. These are not good for multi-threading. But I will see like how the more examples tomorrow. If has any doubt, you can discuss first. Then I will wrap it for today. Anyone any doubt? Anything you wants to discuss?
Yeah, Raj, I have one thing to discuss about the class. So it's not related to the topic, so you can stop the recording.